The origin of a theory, meaning the theoretician's persona and his context, have a definite and important role to play in the theory's initial considerations. That's important again because you'll see similarity in religion. The origin is important. Assalamu alaikum wa rahmatullahi wa barakatuh. So in chapter 3, the first section, the establishment of a scientific theory. So from a scientific point of view, a theory is a set of rules and concepts which explain observed phenomena. It is used to explain what you see around you. The scientific value of a theory lies in its ability to describe and predict events of this world. However, if one also takes into account the social aspect that contributes to the establishment of a theory and its public recognition, then one must take into account the author as well as the usefulness, the benefits you can derive from that theory. So this chapter, therefore, discusses the three main factors required to establish a theory: origin, relevance, utility. And again, as said before, you can subdivide these three broad categories into others, like simplicity, like accuracy, and so on. So going to the first, the origin. From a logical point of view, like pure logic, the validity of a theory should be independent of the person who proposes it. That's interesting, because I said from a logical point of view, well, we can have different logics. So where this idea comes from, that the origin of a theory does not matter, it comes from the Enlightenment, when people wanted to differentiate between science and religion. And to differentiate, they said, okay, the origin does not matter. Why? Because oftentimes the origin of a new scientific theory, of a new way how to see the world, comes from a belief, comes from religion. So because they wanted to distance themselves, like naturalists wanted to distance themselves from religion, they said, okay, the origin doesn't matter. We can take an idea from anywhere, including religion, and make it scientific later on. It's all right. However, experience shows that the status of that person, the theoretician, and his context are critical for promoting a theory, especially when the theory proposes a marginal vision of the world. So indeed, anyone can theorize about anything, but as stated in the first chapter, a theory is taken seriously only if it comes from a reliable and respected source of knowledge. Here I can bring the example of Copernicus. When Copernicus came with his idea of heliocentrism, of putting the sun at the center, it seemed preposterous to the others because they have been living for millennia in a world where the earth was at the center. Because the idea was so preposterous, to take into account and even to discuss it within scientific circle, that person must be trusted. Trust is important. And it turns out that Copernicus had that trust. He had that social standard. He was linked, he had highly placed friends within society. He was notorious astronomer in the field. He was at the peak of his career. He died even few years later after writing that book. So people were expecting something great from him. When they saw what it was, they didn't just dismiss it. They started discussing, like, could it be him proposing that theory? There must be a reason. Let's find out. So in particular, when a person is versed in the science in which he theorizes, the more trusted his opinion will be. Again, Copernicus proposed a new way how to see the universe. He himself was an astronomer, a famous astronomer. So people had trust in him. So similarly, a theory would be swiftly accepted if it validates pre-ordered established notion. And the reverse is true. A theory will be dismissed swiftly if it refutes pre-established notions, unless you have trust in the theoretician. The theory of special relativity, for example, was ignored by much of the British, French, and American scientific community during the decade following its publication in 1905. The theory was initially devalued because it didn't hold into account the popular theory of ether. So ether here is not the Greek ether. It's not like the fifth and purest element. No, ether here is whatever fills the space between two objects. Maybe to give some background, the ether theory comes from the idea that light, if it travels, like from a star to your eye, it needs something to travel into it. It needs a medium to travel into it. On Earth, it's okay, you have air. But if you go beyond the Earth atmosphere, like from the sun to the Earth, there's no air anymore. It's vacuum. Today we call it vacuum. But in the past, they said there must be something to carry the light waves. Let's call it ether. So the theory of relativity did not take into account that ether. In a way, it dismissed it, which is an important point. I'll come back to it in a second. So that was the preposterousness, one of the preposterous ideas of Einstein. He didn't need ether to make sense of the relativity of time. Another accusation is because the theory of relativity didn't provide any immediate material benefits. There were no applicability, there were no practical application for it at the time. Or another accusation, because it was simply not understood, too complicated, or maybe too preposterous. Like when Einstein wrote the paper and he submitted the paper, one anecdote is that the paper was rejected initially because it was deemed too philosophical, not grounded in data enough. Now, the point I wanted to come back is like Einstein proposed the relativity of time, but and that comes through the equations he derived. It turns out that these equations, he's not the first one to derive these equations. There's another guy, another mathematician called Poincaré. Poincaré, a French mathematician, derived really similar, if not the same equations, slightly before Einstein, independently. They knew broadly the work of each other. But Poincaré never accused Einstein of stealing his ideas. He could have. And I read a paper, the paper was asking why so, why Poincaré didn't accuse Einstein. And Poincaré never did so, never went down that road, probably because Poincaré didn't like the way Einstein promoted the theory. Poincaré had specific criteria for scientific theory to be accepted, one of which was simplicity, beauty, like really highly subjective criteria. And for him, Einstein's theory was presented in a way that was complicated. It was not simple enough. And it was, in a way, refuting or dismissing widely accepted theories like the ether. It's possible that Poincaré just didn't like the way Einstein proposed the theory and didn't want to be associated with it anymore. It's an interesting anecdote. So it is indeed the diligence of Einstein and the constructive criticism of his German colleagues that progressively forced the rest of the scientific community to take relativity into consideration. One could argue that truth will prevail regardless of its origin. In other words, that even if Einstein was dismissed, the theory of relativity was dismissed, that theory would ultimately re-emerge through the work of others later on. Well, so history, on the contrary, shows that the status of the person from whom the theory originates and the context of that person matters a lot. To give another example, heliocentrism was taken seriously by Europeans after Copernicus had written about it, because he was famous in the 16th century. Although the first account of heliocentrism was in Greek antiquity, a guy called Aristotle of Samos. He came up with this idea of let's put the sun in the center and let everything revolves around. But that idea was dismissed. Why? Because it had no ground, because it was not useful. It didn't bring any benefits to society. And because there's no direct proof for it, it was simply dismissed. It's only when that idea of the world, that new vision of the world, provided benefits to society, that it was accepted. That's important. So when Copernicus started teaching and writing about heliocentrism, he was already an established astronomer. Again, he was famous. He had a certain high social standard, social status. It is then important to mention that the mathematical model proposed by Copernicus himself was no simpler than the geocentric one, that it was not better suited, like it was not more accurate, based on the astronomical data available at the time. And it did not allow for better astronomical predictions either. So heliocentrism was only provided a new sense of harmony. That's Copernicus' own words. A new sense of harmony. Like to see the sun in the center and to put everything around, revolving around, looks better. That was his argument. But mathematically, in terms of accuracy, it was a failure. But Copernicus already had a reputation, a standard, and his book was long awaited among the scientific community. Even if some rejected the heliocentrism, like Tycho Brahe, for example, the theory was still propagated through discussions. Like if they wanted to refute, they had to give arguments why to refute it. So the discussion made the theory more and more famous. So this example shows that the origin of a theory, meaning the theoretician's persona and his context, have a definite and important role to play in the theory's initial considerations. That's important again because you'll see similarity in religion. The origin is important. More so when you provide, when you push forward an apparently preposterous idea, vision of the world. Like the Prophet ﷺ, when he proposed Islam, like a unique God, to a polytheist context, that idea was preposterous. So trust was important. The Prophet ﷺ social standard was important. Like Allah knows whom the message can and should go through. وجزاك الله خيرا. السلام عليكم ورحمة الله وبركاته.